welcome to area bounded by two polar curves. So we are done with finding area bounded by a curve, just a curve. That is one polar equation. We are coming to two curves, right? All right. When you're going to give two polar equations to find the area bounded by it under a certain interval. So that interval is where you are going to take your upper limit and your lower limit. All right. So we know that from this area formula from a sector, we know that the A should be what? Less than what? The B. That is the assumption attached to it, that the alpha should be less than what? The beta. That's the first assumption. And the second assumption is that the function in terms of theta should be what? Continuous. To be what? Continuous. And non-negative under such what? Domain. Say domain or interval. Alright. So that is that. That's the true condition. It should be continuous. The F function in terms of theta. Alright. So now, dealing with two polar curves, you subtract first of all, be careful. You have to subtract the one on the up from the what? You subtract the lower curve from the what? The upper one. For instance, we have a curve, one is this, then the other one will be like this. You will see that the area bounded will be here. Here will be the area bounded. So this one is the what? The bigger curve, and this one is the smaller curve. You see that is the one with the what? The maximum, the least what? Maximum what? Value. So if the maximum value, you check the maximum value. The one with the highest maximum value will come first. So that will be the what? The R1. That will be the what? The R1. I'll come back to this. That will be the R1. The one with the maximum what? Highest maximum what? Value. That will be the R1. So you can see that. Then the R2 will be the lower one. Don't forget it. If not, you will deviate the question. Subtracting this from this is not the same like this from this. So always check the maximum what? Value. And I've taught you how to find check the maximum what? Value. If you have A sin theta, the maximum value will be the A, and if it's given to you in any of the nature of the curve, you know how to get it. So that is that. Alright. So since we have the upper limit and the lower limit to be the same thing, we can combine these two by factorizing the half out to get it in this form. But remember, you square the R1, you square the R2. Don't forget that if the function is here, this negative will affect the inside. I beg you, don't forget it. This negative will affect the inside. Alright? So that is that. See you for some questions. Alright, welcome back to our first question under area bounded by two polar curves. So we have R1 to be 3, R2 to be that. Alright, so the first thing to do is for you to sketch your polar curve. So you draw your table, then you go by the steps. You know R is equal to 3 is a circle. You know this is equal to, the A is equal to B. So this is what? A cardboard. So you know all these things already. Alright. So now, let's go. So the first thing to do is to do what? Is to sketch it. But for me, I'm going to use the technique. Alright. Because of time and the content here is finding the area. Alright. So now, to sketch it, first of all, you have to go for the point of what? Intersection. So you go for the point of intersection, then you have to equate R1 to what? R2. So having the R1 and the R2, you equate the two. And when you equate the two, you solve for what? Theta. And when you solve for theta, you're going to get theta to what? Pi over what? 3. Good. So that means that there's going to be a point of intersection at pi over what? 3. So this is going to be pi over 3 or negative pi over what? 3. Because on the anti-clockwise, it will pass through pi over 3, and And the clockwise, it will pass through what? Negative pi over 3. So the techniques, that's what we have to do. So let's say that we have this 0, we have our pi over 2, we have our pi, we have our 3 pi over 2. Then pi over 3 is what? 60 degrees. So this is just a rough sketch. So let's indicate. Alright, so let's indicate our pi over 3 here. Then you know that here will be what? Negative pi over 3. Alright, this will be negative pi over 3. Now, from this, r is equal to 3. You know that this is cardboard, and the maximum will be what? A plus b, which is 4. So you get 1, 2, 3, 4. I hope you can see that. Alright. And you can also see that the 3 is a circle. So you go by a circle. This is serious, so let's take it like that and go. If not, I'll be doing something that you will not like. Beautiful. Let's take it like that. We know the point of selection is pi on 3 and negative pi on what? 3. So that means that we now want to sketch the cardboard. The cardboard is having a maximum of what? 4. So it will pass through this side. Alright. And the minimum is 0. And you know cardboard will be like this. Don't forget we are passing through this. So a cardboard will go like this. A cardboard will go like this, pass through this, come back and pass through this 4. Yeah, let's take it like this. That's how it's going to be. So it is going to pass through this. So the area we are finding is the area bounded by these two, which is this. So the area we are finding is this. Not this and not that. The area bounded by the two is exactly what is what? Here. Okay? Good. So that is what we are finding. So you can take your integral, the limit. You can take it from negative pi on 3 to pi on what? 3. So you can take it from negative pi on 3 to pi over 3. Half of. And you know that it's going to be r square 1 minus what? R square 2. But bear in mind, it's always the upper minus what? The lower. The curve. Now looking at these two curves, you can see that the r is equal to 3 is under the cardboard. Because you see, this one is what is coming first, and this one is inside of it. So when you subtract this from this, if you subtract this from this, you are wrong. Please be careful here. So here is going to be rather this from this. So here is going to be the cardboard first. 2 plus 2 cos theta all squared minus this squared the theta. It's not 3 squared minus this. And how to know it is from the graph. It's from the what? The graph. You know finding the area upper minus the what? The lower. So you subtract this curve, the cardboard from what? This. Sorry, the circle from the what? The cardboard. So that's how it's going to be. Don't forget that. And also, it's not always that you can choose from negative pi. In fact, I always like choosing my lower to be what? 0. And I have told you the reason why. So here, you can take it from 0 to pi on 3. But remember, you multiply by what? 2. Good. 2. 2. I heard you saying 2, 2, 2. Yeah. So the area is going to be that. So you can get from 0 to 8, then you multiply by 2. I have taught you how to equate the 2 in order to get the point of what? Intersection. So don't forget that. I have also taught you that we subtract the upper from the what? From the lower. In fact, you can even check from the maximum. You know here the maximum for the carbon is what? 4. And this one is 3. So which one is the bigger one? You see it. Alright, so now here, let's go. This will cancel this. So this will be equal to. Alright, so we are multiplying this by itself, right? So 2 will multiply 2 plus 2 cos theta plus 2 cos theta will multiply 2 plus 2 cos theta. How you can see that? This will multiply the whole of that, this will multiply the whole of that. Minus 9 the theta. And that's what we are going to have. Beautiful. So this is going to be equal to integral from 0 to pi on 3. This and this. I love after getting I always laugh from this part. Calculus! Oh my God. Love calculus, okay? Alright. So this and this is 4 plus this and this is cos theta plus this and this 4 cos theta plus this to this 4 cos square theta minus 9 the theta. Beautiful, beautiful. Please, how I can clean it? Good. Go. All right. Let's continue. So now here, integral of 0 to pi on 3. Now you can see the constant. 4 minus. Okay, so let's first add this to this. You get what? 8 cos theta plus 4 cos square theta, then minus 5 theta. Beautiful. Oh, let us get to this. I hope integration of this is just don't be scared. Integration of this, oh, this one prior, they know thing. Alright. So you use the short method and go away. If you don't know how to go by that, go and watch the previous video. Alright, so now to integrate there is no problem. 8 cos theta plus, so here you change this, right? So the 4 will come alright, but you change this. This one is what? Half 1 plus cos is 1, right? Cos 2 theta. Or you can see that. So this we are having here is the same as this. Alright, minus 5 theta. So now, having this, we can leave it in the list form. 8 cos theta plus this will go here, 2. Now, the 2 in the outside, right? Multiply by the 1, you get 2 plus 2 cos 2 theta. In fact, I love calculus. Take your time with it and you also love it. Minus 5 the theta. So here, let's use the short method and go our way. Wow! So here, now we are taking the integration. Integrate this, you get what? Forget the constant there. That will give you 8 sine theta. Alright? Oh, there's a constant here, there's a constant here. Okay, you don't worry, we will deal with that together. plus, let's jump this and come to this. So if you integrate this, how you can see what you get? Simple method. 2, let's go. Sine 2 theta. All this over 2. Beautiful. All that over 2 because this is not what I'm considering. Sine 2 theta, all that over 2. Minus now 2 minus 3, right? Negative 3. So here will be negative 3 theta. So when you integrate negative 3, you get what? Negative 3 theta. Alright, then you bring your, this thing, don't forget to pi on 3. So this is going to give you 8 sine theta plus sine 2 theta minus 3 theta. 0 pi on 3. So, first test. Because we are going to do substitution, upper minus what? The lower. Oh, you know sine theta will be 0. So after testing, knowing that it will be 0, that means that the 0 side will be 0. So the upper minus the lower. 8 sine theta over 3, sorry, pi over 3, plus sine 2 times pi over 3 minus pi over 3. All that minus 0. So this is going to give you, alright. So your final answer is going to be, okay. So here, it's going to be like this. Negative pi plus 8 root 3 over 2 plus root 3 over 2. And when you combine this, this is the same as this to this. You get what? 9 root 3 all over 2 minus pi. So x cubed units. So this is going to be your final answer for that. Alright, let me see if I can add you more questions.